Okay, what we're going to do is start taking measurements. So we're going to start at 0 seconds. I'm going to start the timer. Oops. Sometimes my thermocouple in the ice keeps coming out. So we've got 34.6 degrees in the warm, and hold on. It's hard to get the temperature of the ice. It keeps moving around. 0.7. So then after a minute, we're going to take data again. I am trying to get the thermocouple right inside of the ice. It's a little difficult. I guess that's, it should be 0 degrees, but okay, there we go. Sometimes it's not touching the ice. Okay, we're almost there at 1 minute. So 34.4 in the warm temperature and 0.4 degrees in the cold temperature. So that's the 1 minute mark. Now, what is the mass of the ice? We're going to measure that once we're done. So right after we're done and we're sure that all the ice is melted, we're going to measure the mass of the ice. What we're going to do is measure, how we're going to measure it is it's going to be melted. You already know what the mass of the water is, the warm water, and you know what the mass of the aluminum cup is with the water. So you're going to take our final mass measurement and subtract it off to find the mass of the ice. Okay, get ready for our measurement at 2 minutes. We have 34.2 and 0.4. So we've got 30 seconds to go. Okay, get ready. We have about 10 more seconds. So it's 34.0, and we have one more measurement to take. Then what's going to happen is I'm going to take some ice and put it like into the calorimeter cup, and then that's going to be right at the 5 minute mark. We are going to take the final, the temperature of the system, combined system, right at the 5 minute mark, and then every minute after that for a while. Oops. Okay, 30 more seconds. Okay, get ready for the 4 minute measurement. .8 and 0.4. So basically, ice is staying at 0.4. That first one, the 0.7, I didn't quite have the thermocouple in the right spot. I guess it's always hard to measure ice because there's a lot of air pockets in between it. You don't get very good thermal conduction on it. So at this point, we can actually, we don't have to measure this one anymore. So what I'm going to do is take this off to the side, sorry. And I'm gonna get ready. I'm gonna dry off some ice cubes. Again, you don't want liquid water on the ice cubes. And I've got about 13 seconds to go. So, all right, I've got some 4, 3, 2. So get ready to write down the first measurement. So 33 point, no, stick it in there. All right, all the ice is now in. And our first measurement is 30.8. So 30.8 is the first measurement of the combination. And what I'm going to do is set this one up. So at the 6-minute mark, we'll take our next measurement of the combined system. And you can see now, I put the ice in the calorimeter cup, and this thermocouple is measuring it. You can see it's moving downward because the ice is melting. And it'll keep going downward, and I'm gonna stir. I'm gonna peek in every once in a while to see if all the ice is melted. Okay, we're almost at the 6-minute mark. .3. So I'm going to peek to see how much is the ice melts. Oh, it's almost all melted. Okay, so the ice is almost completely melted. I'm just going to mix it around a little bit with thermocouple. So it should stabilize now, since it looks like the ice is melted, and this probably is going to be close to the equilibrium temperature. But again, remember, we use the method of the line of mixing, so we're going to take measurements for the next 13 minutes and then plot all of it out and extrapolate to 5 minutes to figure out what the equilibrium temperature is. Okay, get ready for the 7-minute mark. 22.4. So this is actually quite close to room temperature. It's probably not going to change that much from this point. That actually is sort of the idea of using warm water at the beginning. Because you have less heat transfer, the rate of heat transfer increases if the temperature difference between the room temperature and the calorimeter cup is greater. So since 22.5 is fairly close to the the temperature in the room, the temperature in the room is like around, I probably should, let me see, it's about 19, so it's a little cooler than that. All right, we're coming up on the 8-minute mark. .5. So as I was saying, and the room temperature is around 19 degrees Celsius. It's a little colder than this. It's only within a few degrees, so we're not going to see a large amount of change. Now, if the equilibrium temperature was much higher, you would see a lot more heat transfer to the room. It actually looks like it's getting a little higher. It's kind of interesting. Oh yeah, you ready for the 9-minute mark? .6. Okay, get ready for the 10-minute mark. $22.6. Right, here comes the 11-minute mark. Get ready to write it down, and it doesn't change that much. Okay, we're coming up on the 12-minute mark. Wow, oh my God, it just changed. How exciting. It's actually going up rather than down. 22.7. All right, I am just going to mix it a little bit. Okay, mixed it. Just twirled it around.